Assalamualaikum warahmatullahi wabarakatuh. Ketemu lagi di channel Zona Tutorial Matematika. Di sini tempat kalian belajar matematika. Oke?
Welcome to Premath. In this video, we have got this rectangle DBEF fully inscribed in a yellow shaded right triangle ABC, as you can see in this given diagram, such that the diagonal of this rectangle is 17 units, whereas this vertical segment AD is 4 units, and moreover this horizontal segment EC is 30 units. And now our task is to calculate the area of this yellow shaded triangle ABC. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's focus on these two triangles, this triangle ADF and this triangle FEC. And we can see that these angles, this angle and this angle, are 90 degrees since we are dealing with this rectangle. And now let's make an observation. We can see that this angle and this angle, they are congruent angles since they are our corresponding angles. If this angle is alpha, then this angle has got to be alpha as well. And likewise, this angle and this angle, they are congruent as well, since they are our corresponding angles. If this angle is beta, then this angle has got to be beta as well. So therefore we can see that these two angles, alpha and beta, are complementary angles. So therefore we conclude that these two right triangles, triangle ADF and this other triangle FEC, are our similar triangles according to angle-angle similarity theorem. And since they are similar triangles, so we're going to have a proportion. In other words, the ratio of these two side lengths, DF and AD, is going to be equal to the ratio of EC and FE. And now let's focus on this rectangle DBEF. I'm going to label this side of this rectangle as lowercase a. Then this side is going to be lowercase a as well. And likewise, I'm going to label this side of this rectangle as lowercase b. Then this side is going to be lowercase b as well. And now let's make an observation. We can see this side df is lowercase a. So I'm going to replace that one with lowercase a over here. The side AD is 4 units. So I'm going to replace that one with 4. And this side EC is 30 units. So I'm going to replace that one with 30. And finally, this FE length is lowercase b. So I'm going to substitute that one for lowercase b, as you can see in this next step. And now we are going to cross multiply. So therefore, our A times B value turns out to be 4 times 30 is going to give us 120. And I'm going to label this one as our equation number 1. And now let's focus on this right triangle FEB. And we are going to apply the Pythagorean theorem on this triangle. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, the hypotenuse of this triangle is 17, whereas our two other legs are lowercase a and lowercase b. So let's go ahead and fill in the blanks in this Pythagorean formula. So we got a square plus b square equal to our hypotenuse is 17 square. And I'm going to label this one as our equation number 2. And now let's recall this famous identity. A plus b whole square could be written as a square plus b square plus 2 times ab. And here we can see a square plus b square, our value from equation 2 is equal to 289. So I'm going to replace that one with 289 over here. And likewise, this a times b value from equation 1 is 120. So I'm going to replace that one with 120 over here. So therefore, after the substitution, that is going to become a plus b whole square equals to 289 plus 2 times our ab value is 120. And I'm going to undo this square by taking square root on both sides. And here we can see our a plus b value turns out to be positive 23 units. And I'm going to label this one as our equation number 3. So thus we are ended up with these 3 equations. And here I have copied down this equation 3, a plus b equals to 23. And this equation 1, a times b equals to 120. And here we can see this represents the sum and this represents the product. And now let's recall the Vieta's formula for this quadratic equation. X square minus the sum times x plus the product is equal to 0. And in our case, our sum is 23, whereas the product is 120. So therefore, for this side of this rectangle, lowercase a, this formula is going to become a square minus the sum in our case is 23 times a plus the product is 120 is going to be equal to 0. And now we can see we got this quadratic equation and we are going to solve it by grouping and factoring. And now let's focus on 120, the constant. I'm going to just copy it down over here. And 120 could be broken down to 8 times 15. And we can see if we add 8 and 15, that is going to give us 23. That's what we got in the middle. So therefore, we are going to tweak this middle term. Negative 23a could be written as negative a times a minus 15 times a, as you can see in this next step. And now we can see between first two terms a is in common, and between last two terms negative 15 is in common. So therefore I can factor out a. So we got a minus 8. Here I'm going to factor out negative 15, and we got a minus 8 equal to 0. So therefore we can write a minus 8 times a minus 15 is going to be equal to 0. And now we are going to separate these two factors, as you can see in this next step. So therefore for this equation, a value turns out to be equal to positive 8, and for this equation a value turns out to be equal to positive 15. So thus we are ended up with these two values of a equals to 8 and a equals to 15. So therefore we are going to consider two scenarios. In scenario 1 our a value is going to be 8, and for scenario 2 our a value is 15. And now let's focus on this equation 3. And here I have copied down this equation 3 over here, a plus b equals to 23. And now I'm going to substitute this a value 8 over here, as you can see in this next step. And now I'm going to subtract 8 from both sides. This 8 and negative 8 is gone. So therefore our b value turns out to be positive 15. So thus in this scenario 1, for a equals to 8 value, our corresponding b value turns out to be 15. And likewise, let's focus on this scenario 2. And I have copied down this equation 3 over here as well. A plus b equals to 23. And now I'm going to substitute this a value 15 over here, as you can see in this next step. And now I'm going to subtract 15 from both sides. They are gone. So therefore our b value turns out to be equal to positive 8. So therefore for this a value equals to 15, our corresponding b value turns out to be 8. And now let's focus on this scenario 1. Our a value is 8. So I'm going to substitute this A value 8 over here, and likewise our B value is 15. So I'm going to substitute this B value 15 over here, and we can see that our this AB length is going to be 4 plus 15. That is going to give us no wonder 19 over here. And likewise this BC length is going to be 8 plus 30 is going to give us 38 over here. And likewise for scenario 2, if our A value is 15, in other words if this value A is 15, and likewise our B value is going to be 8, then our this AB length is going to be 4 plus 8 is going to give us 12. And likewise this BC length is going to be 15 plus 30 is going to give us 45. And now we are going to calculate the area of the triangle in this scenario 1 and the scenario 2 as well. And now let's recall the area of a triangle formula. Area is always equal to a half times base times the height. So therefore for this scenario 1, the base of this triangle is 38 and the height is 19. So therefore the area of this triangle is going to be a half times our base is 38 times 19. So therefore the area of this triangle in scenario 1 turns out to be 361 square units. Likewise, now we are going to calculate the area in this scenario 2. So the area is going to be equal to a half times our base, in our case is 45, times the height is 12. So therefore the area of the triangle in scenario 2 turns out to be 270 square units. So thus the area of this yellow triangle is going to be either 270 square units or 361 square units as well. Thanks for watching.